Hi everyone. I'm doing my case study on the 1965 Palm Sunday tornado outbreak. Okay, so because we live in Hawaii, we don't have tornadoes like how lots of um, places in the mainland have. We have water spouts, which are tornadoes that form over a body of water, but it typically doesn't touch land. It dissipates before it comes on land. So let me go through what a tornado is so we can get familiarized before I go into what happened on the Palm Sunday tornado outbreak. A tornado is two opposing winds that move at different speeds. The area between them will rotate around a horizontal axis. If one end of the horizontal air column gets caught in the supercell's updraft, it will tilt vertically, forming a funnel cloud, which is pretty much this is the two opposing winds, and then it will make a horizontal funnel. And then when the supercell is updraft, it will tilt vertically, forming a funnel cloud, which is what's happening right here. And the continuous upward energy of the supercell elongates the funnel cloud and causes it to spin to tighten and speed up, which is like, like a ice skater when they do like their spinning. The closer they make their arms to their body, they'll spin faster, and that's pretty much what's happening right here. And when the hail and rain push downwards, it pushes the tail of the funnel um, down, and when it finally touches the ground, it becomes a tornado. And most tornadoes form from supercell thunderstorms, which is a long-lived thunderstorm whose updrafts and downdrafts are near balance. So you need warm, moist air and cool, dry air. When these two air masses meet, they create um, instability in the atmosphere, which causes this whole phenomenon to happen. Um, and the scary thing is that tornadoes can happen at any time of the year and like at any time of the day. Just you never know. It's just when there's the instability in the atmosphere, it just happens. Just luckily we live in Hawaii and we don't have that kind of stuff. Um, but in there's a place called Tornado Alley, and it makes up in the states of Nebraska, South Dakota, Oklahoma, Texas, and Kansas. Um, tornadoes typically strike regularly in the spring and early summer. Many houses in Tornado Alley have strong basement shelters just for that reason, because of tornadoes being so, like, you never know when it's gonna happen, so they have to take cover really quickly and then have a safe place. But so the cold air comes from like the upper states and the warmer, and that causes that. This is like a perfect spot. It just makes it a perfect area for tornadoes to happen. So how they rate the tornadoes is the Fujita scale. It was created by Dr. Theodore Fujita of the University of Chicago in 1971. The Fujita scale differentiates tornado intensity and finds the correlation between tornado damage with wind speed. And this is the original scale, but over time, scientists have did like major research and found flaws. So um, the National Weather Service unveiled the enhanced Fujita scale in 2006. It's a little bit more accurate. So here are some of the parameters. So for EFO, its estimated wind is 65 miles per hour to 85 miles per hour, and the damage is pretty light. It's just like chimneys and branches are broken off, trees and rooted trees pushed over, and signboards damaged. The scale rating for EF1 is estimated wind is 86 to 110 miles per hour, and the potential damage is moderate. Like if you see in this picture, like the roofs, like the surface of the roofs are getting pulled off, and mobile homes are pushed on the side, and cars are pushed off of roads. The EF2 rating is estimated winds of 111 to 135 miles per hour. Significant damage. Mobile homes demolished, large trees snapped, and high-rise windows broken and blown in. And the scale rating for EF3 is estimated wind speed is 136 to 185 miles per hour. And the damage is pretty severe. Roofs and walls are torn off, well-constructed homes, trains overturned, and heavy cars lifted off ground and thrown. Oops. Sorry. The EF4 rating is 166 miles per hour to 200 miles per hour. And as you can see, this is devastating. Well-constructed houses leveled and structures with weak foundations blown away. The EF5 scale rating is over 200 miles per hour. And incredible damage. Strong framed homes lifted off foundations and carried considerable distances or disintegrated. Cars are missiled through the air and concrete structures badly damaged. So pretty much it's nothing. There's nothing there after that. Okay, so the Indiana tornado was on a Palm Sunday on April 11th, 1965 in the Midwest states of Indiana, Ohio, Michigan, Wisconsin, Illinois, and Iowa, with recorded 47 tornadoes. It was the second biggest outbreak on record at the time, third now. In the Midwest, 271 people were killed and 1,500 injured. 1,200 of them were in Indiana. The outbreak lasted 12 hours and is amongst the most intense outbreaks in terms of number, strength, width, path, and length of tornadoes ever recorded. And they even had 4 double twin funnel tornadoes, which is really scary. And like even in Midway, in Ohio, a trailer park, it was disputed. All of them were the highest on the Fujita scale was F4s, but this one was disputed in Ohio was a F5 because like 25 homes were literally wiped off the face of the earth. Like there was no remnants of there was no sign of that there was ever houses there. It was just completely gone. It's just like a plain with nothing there. Um so this is called a tornado outbreak because um the occurrence of multiple tornadoes spawned by the same synoptic scale weather system. The number of tornadoes required to qualify as an outbreak typically are at least 6 to 10. So this is well over by having 47 tornadoes. Um, and then the outbreak tornadoes outbreak in the same day within the same region, which is it was in the Midwest, and it was within 12 hours. On the outbreak description, when it happened, it touched at around 12:55. The first tornado touched down in Iowa, and it was scaled at F4 um, on the Fujita scale and spawned from the thunderstorm cell detected near Tipton, Iowa. This was the first hard evidence for the Weather Service regarding the growing threat of severe storms, which spawned dozens of tornadoes over the next 12 hours. So in this specific tornado, Dr. Fujita, the one that did the Fujita scale, he discovered suction vortices during this Palm Sunday tornado. It had previously been thought that the reason why tornadoes could hit one house and leave another across the street completely unscathed was because the tornado would jump. Like if you could see right here, like it's just totally demolished, and then there are some that are like completely untouched. But Dr. Fujita discovered that the actual reason is most destruction is caused by suction vortices, small intense mini tornadoes within the main tornado. So there's the tornado's going, and there's certain parts in the tornado that are stronger, which causes the destruction, and the weak spots in there. That's actually what's happening where you see this kind of areas where places are totally demolished, where the suction vortices are, but then you see like this building right here and right here that didn't get touched because they just so happened to land in the weak spots of the tornado. So the aftermath is pretty bad after a tornado. It's just horrible. The reason why there was a large number of deaths and everything is because, especially in 1965, there weren't as many like ways to get warnings out, because it's pretty much just the TV and all that, and radio. But a lot of the warning system failed for this one because a lot of public didn't receive it, and also the public wasn't aware of the difference between a forecast and an alert. So from this tornado also, it established the official watch and warning procedures. So like people knew what it was after this tornado. The only President Johnson came to look and aid a lot of the victims of this tornado. A lot of the survivors, they're grown, and some of them are really old, and they can close their eyes and pretty much remember everything of what happened that day because it was so devastating to them. And they say that, that it's just hard to explain the feeling when you have like a full house crumble down on you. So I'm happy that they started doing more awareness and tips for people that live in this area. So like in Indiana now, they have this a drill they do yearly, and it helps them be prepared for a big tornado disaster. And now it's everybody knows what a tornado watch is. Tornadoes are possible in your area. Stay tuned to the radio or television news. And then a tornado warning is it's either on the ground, a tornado is on the ground, or has been detected by a Doppler radar. So seek shelter immediately. So a lot of people that live in that area know now to seek shelter as soon as possible when they hear a warning. It's not just a watch, but yeah. So that was it for my tornado case study. I hope you enjoyed it. I enjoyed searching about this disaster. It was sad to look at and see how many people died and the devastation to the area, but the good thing is that along the way we've gotten smarter and teaching people how to react to these kind of disasters. Anyway, have a nice day and bye.